Last lesson, guys, we started solving inequalities. So we're given something with like a less than or a greater than, and we're asked to get x alone. We started those last time. Today we're doing the same topic, except we're doing more difficult examples. Now specifically, we're going to have examples where there's a variable, usually an x, on both sides of the inequality sign. Okay, so that's kind of like our biggest goal for today, being able to solve stuff like that. You solve inequalities the same as you did equations, ones that have equal signs. The only difference is that you must remember to flip the sign around when you multiply or divide both sides. So that's what you're doing to both sides to get x alone. When you multiply or divide both sides by a negative number. Okay, if you can keep that in mind the whole time, like, do I need to flip the sign around? Do I need to flip the sign? That is the only thing that's different when they change it to a less than or a greater than as opposed to an equal sign. Okay, you have to do this so that way you represent the solutions accurately. Okay, we will have to graph these on the number line and show where the answers are. If you don't flip the sign around, you're going to show the opposite side of the number line as the solutions. Okay, so be really careful to do that. So number one, I'm going to start if you need to, so you can see what's on either side of the inequality sign. You can draw that line. Hopefully you don't need to do that. And I'm going to start by getting the x's together here. So I would subtract the smaller x from both sides. So I'm going to move the 3x over. I subtracted from both sides, so I do not need to flip the sign. I'm constantly thinking about that. Keep it a less than. Now it's just a two-step inequality, so I'm going to add the 4, and then I'm going to divide by 2. And on the solve line, they want the answer, so notice I divided both sides by a positive 2, not a negative, so I don't need to flip the sign. The answer is just anything that's less than 6. So any number less than 6, I can plug in for x, and it works in this inequality. So I want to represent that on the number line. So I'm going to put 6 in the middle. See, I'll just put 7, 5. Make sure you get a couple other numbers on there so I know you know bigger numbers are to the right, smaller to the left. So I want all the numbers smaller than 6. So that would be all the numbers 5 and smaller. 6 does not work because I don't have the or equal, so I want to do an open circle above it. Okay, there's only 4 examples today. There's no back to the notes, which is awesome. I want you guys to do number 2, solve it and graph it. I'm going to jump down and do the 2 at the bottom, and we're done. So same thing, if you need to draw the line, do that. Always, 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 you should distribute first if you can. So I'm going to take care of that first. That's the same as when I was solving equations. So that would be minus 12. Okay, now I'm going to get the x's together, so I'm going to subtract 4x. So then I have 6 minus 12, and that's 5x minus 16. Okay, I want to combine what's over here, so it's on the same side of this line, so I just do the problem like it looks. 6 minus 12 is negative 6. Now I've just got a two-step inequality here, so let's see, I want to get x alone, so I'm going to add 16. And that gives me 10 is less than or equal to 5x. And then I divide by 5. And I divided by a positive 5, so I'm not going to flip the sign. I'm going to leave it 2 is less than or equal to x. Now, I think you guys will find most of the time with these problems, if you always move the smaller x over when you combine them, you really will avoid this flipping the sign thing. Not every time, but a lot of the examples, if you move the smaller x, you won't have a negative number of x's. Therefore, you usually won't have to flip the sign around. Okay, but when I have to graph this, people will run into problems. It might be more helpful if you flip it around. Sometimes it's easier to read when the x is on the left, but that's totally up to you. If you do flip it around with x on the left, 2 on the right, the mouth is opening towards x, so the mouth needs to open towards x when you flip it. So the solutions here So I'm looking at 2. 2 is the boundary number. I want all the numbers that are bigger than 2. So x should be bigger than 2. So I know I want like 3, 4, 5, all the numbers to the right. And I can include x because I've got the or equal to. So 2 is the solution. All right, last one. So if you have a proportion, which is what this is, remember that we always cross multiply to get rid of the fractions. Okay, we did these in Unit 1. They were on our test last unit. So I'm going to cross multiply. I'm going to keep the sign as is. Here's the issue. The variable part, so like the subtraction problems here. I know I need parentheses around them, and it does matter. In an equal sign, you can flip-flop what's on either side. It doesn't matter. It does matter here because the left side is greater than the right side. So this x minus 1, it's on the left-hand side of the sign. It needs to stay on that side. And the 2x minus 4, it needs to stay on that side. Okay, so be careful. The variable expression, keep that on the correct side. And then, okay, so I would multiply 9 times the x minus 1. And I'm going to multiply the 6 times the 2x minus 4. Okay, so I know I'm going to distribute on both sides here and get 9x minus 9 is greater than 12x minus 24. I'm going to move the smaller x, so I'm going to subtract 9x's from both sides. Then I'm going to add 24. And then divide by 3, run out of room. Same thing, because I moved the smaller x at this step, I didn't have to worry about flipping the sign because I divided by a positive 3. So I'm going to leave it a greater than, and that would be 5. If you want to flip it around for the sake of making graphing just a little bit easier, the 5 is bigger, so the mouth needs to open towards 5 when you flip it. So where are the solutions here? Well, let's see. X is smaller than 5. So it's any number smaller than 5. And I cannot include 5 as the solution because it doesn't have the or equal to.